last week, and I thought for our Memorial Day special, we would revisit a couple of the episodes on ChatGPT and being responsible. First up, Marco Casalaina on how ChatGPT works with grounding. Second, Sarah Bird on being responsible with large language models. And last but not least, Marah does an awesome demo on how to be responsible with classical machine learning by looking at data. Let's start with Marco.
Now, here we go. This is the administrative environment behind ChatGPT. So I'm in Azure OpenAI, and in here we have this new ChatGPT playground. And in the ChatGPT playground, well, I can have my own ChatGPT. And by the way, there's this common misconception that there is one ChatGPT, but that's not really true. There is one chat.openai.com, their consumer ChatGPT, but you can make your own ChatGPT with Azure OpenAI. So there can be many instances individually of ChatGPT, and this one is mine. So here's what I'm going to do. All right. So this thing at the top here, the system message, or what we call the meta prompt, this is very important. This is where you give it its instructions. This is where you tell it what its tone should be. This is where you tell it what not to do. For example, maybe you want to say, don't make jokes about politicians or something like that.
Right.
So you give it all these instructions up here in the system message, and I've done none of that. So right now I got a wide open system message over here, and basically that means it'll talk about anything. So down here, let's say I wanted to talk about the Greek island of Santorini.
Okay.
All right, and I submit that, and there it goes. Okay, it's telling me whatever it remembers about Santorini. That's great. But let's say that I'm a business, like let's say I'm Microsoft, and I want to make my own instance of ChatGPT, but I only wanted to talk about Microsoft stuff. Like I don't just want to talk about whatever, right? So I'm going to have to program this thing so that it only talks about Microsoft stuff. And so over here, I have done just that. This here, this stuff, this is the programming. This is what I meant when I said English is the hottest new programming language. So here I've written, you're an AI assistant called Softy. You help people find information about Microsoft products. You will decline to discuss any topic other than Microsoft products and services. So this is like a commandment. You will not talk about other stuff. And you'll end each response with an emoji. That's a Seth Juarez special. I know that's a meta prompt you like to add.
That's right.
I've seen you do it. And
That's
so
right.
now, down here, I have it already typed in. Tell me about Santorini. Now, Santorini is not a Microsoft product. It is a Greek island. And it says, I'm sorry, but as an AI assistant, I can't provide information about Santorini because it's not a Microsoft product. Now, of course, if I ask it about a Microsoft thing, does Microsoft offer M365 in Germany, for example, that most certainly will work.
So as it's answering, I'm going to ask a couple of questions. That's okay. So this here that I'm looking at, and look, it did the right answer, of course. This thing I'm looking at, this is like ChatGPT, but specific to you. Can you explain what we're looking at? This Chrome here.
Yeah. So this stuff we're looking at here, this is my ChatGPT, right? I got my own ChatGPT, and the data that goes in and out of this ChatGPT, and that could be these prompts or the responses. That's my data. And I get to keep that data, and that data doesn't go back and go train other GPTs or anything like that. This is my own instance of ChatGPT that I can program in any way that I want.
And this here is just basically a playground where you can test stuff out. But is there like an API endpoint as well that you can use that's only for you and your business?
Absolutely, absolutely. So when I make a deployment over here, that creates an API endpoint that I can now use to call my ChatGPT from my own business, my own website, my own mobile app, whatever.
And that's what it's meant then by Azure OpenAI when you're using Azure, specifically cognitive services with your own OpenAI cognitive service, you effectively have your own model for your own data for your own stuff.
That's right. That's what it is.
Amazing. All right, well, keep showing us more stuff. This is cool.
All right. So there is more. There is more. Okay. So now there's something that Bing did that you might have noticed here that this raw ChatGPT over here, my own ChatGPT, didn't do. Bing did something very interesting here. See, when you submit a prompt to ChatGPT, we call each one of these things a prompt. When you submit a prompt to ChatGPT, it just spits out whatever it knows from memory. So it just kind of remembered that, yes, Microsoft offers Microsoft 365 in Germany, but it didn't really go look that up to verify that that's true in any way. Bing, on the other hand, does do that. So you notice when I made this query here, it actually went and looked up prompt engineering for ChatGPT, and it used that information that it found. So it found this information from all these sites over here, and it used this information to give me this response. So it didn't
Right.
just make the response from memory, it's grounded in data.
Of
So
course.
now, let's say again that I have my own business. Let's say I'm Microsoft, and I would like to put up a conversational experience, but unlike Bing, I don't just want it to hit whatever on the web. I want to specifically say, there are these sets of data that I would like it to be able to consider in making its response. So I can do that. And so here, I'm going to show you both how to do that, and also I'm going to kind of peel back the covers a little bit on how Bing is doing this, so y'all can get a look at what's really
This is cool.
happening under
This is
here.
cool. I'm excited. I'm excited.
It's going to be cool. All right, so here's the deal. So I have made this bot. Actually, my colleague Pablo made this bot. And this is ChatGPT on top of Azure Cognitive Search. And Azure Cognitive Search is a search engine, but unlike Bing, it doesn't just automatically index the whole web. It's a search engine that you tell it what to look for. And you say, I only want you to consider these URLs, these documents, and it'll do that. And so we have this Azure Cognitive Search, and it is searching across our employer health plan. Let's say that I'm making a kind of an HR benefits bot for my internal employees. So we have all these documents in here in the search engine about our health plan. And I'm going to ask, does my plan cover new glasses? And here we have it. It gives me this response. It does cover new glasses, actually. That's great. It tells me the different kinds of plans and so on. And this is a conversation I can actually keep going with this because it's asking me for more information. But like Bing, you notice that it did a query and it actually is returning also citations, but these citations are documents that I am indexing that might be only inside my business and might not be publicly available on the web. What's really interesting here is if we look at, and this is maybe something I wouldn't show, my employees or whatever, but I love this tab, the thought process. They call it the thought process. And so here's what it was thinking, so to speak, in informing this. So I asked this question up here, does my plan cover new glasses? And it didn't just send that straight to ChatGPT. And this is ChatGPT that's running behind this. But it didn't just send it straight to ChatGPT. Instead, it actually generated a query from that first, employee benefits glasses coverage. So it decided to go query that. And it found some documents about that, employee benefits glasses coverage. So before this ever got to ChatGPT, it did this query. And it found these documents. And one of the things that cognitive search does is it chunks up the document. So it can take little individual pieces of the documents, because what is also true about ChatGPT is that there is a token limit. You can only give it so many characters in your prompt before it kind of throws up.
Right.
So you can't just throw all your documents in there. That'll never work. You have to have a search engine that will find the most relevant little bits and say, these things are relevant. And then you can kind of throw that in there, which we'll get into in just a minute. So we did this query. And finally, everything under the prompt in this thought process is what it's actually feeding to ChatGPT. So it's feeding to ChatGPT all this stuff down here. This first part is the meta prompt. It's kind of like what I just did. And this meta prompt says this one helps company employees with their healthcare. And it also says, don't generate answers that don't use the sources below. So don't just generate whatever, right? Only if it has substantiation and so on. So there's a number of instructions in here. And then right into the prompt itself, we are injecting the data that it looked up. These are the pieces of documents that it found. And we're giving this directly to ChatGPT. And finally, underneath all of that is my little question. Does my plan cover new glasses? So ChatGPT by itself could not possibly answer this question without this data grounding. In fact, if I go back into the raw ChatGPT and I say, does my plan cover new glasses? That is going to give me a nonsensical response because it has no idea what I'm talking about here. I'm sorry. At least it knows it doesn't know. But here, it has all of this information to use, and it does use that information to form this response right here that it's created. And so this is how you're able to inject your own data into ChatGPT, which incidentally is covered in this blog post by my colleague Pablo. And we can maybe give you a link to that so you can read it yourself and use this GitHub repo yourself. But this is fundamentally how all of these things like Bing actually work.
All right, my friends, you just saw Marco Casalaina on how ChatGPT works, along with grounding next up, Sarah Bird on being responsible with LLMs. Hello, and welcome to this episode of the AI Show. We're talking all about being responsible with large language models with my friend Sarah. Sarah, how you doing? It's been a while.
I'm great. Happy to be here. Been a busy time working on LLMs.
I was going to say fantastic, but it's been a lot. I mean, it's a lot. Nobody's ever been as interested in this stuff as they have been nowadays. I mean, what do you think?
Yeah, I think it's been absolutely crazy, but also I think very exciting. I know it's even a hot topic of, wow, we're moving so quickly with LLMs. Are we ready to do this responsibly? And I can share sort of from how it's felt to me on the inside is absolutely, like we've been working on this for years. And so the last 6 months is just the chance to go faster, have bigger impact, do more at scale. And it's been a wild ride, but absolutely extremely rewarding.
Awesome. But for those that don't know you, Sarah, why don't you introduce yourself?
Yeah, I lead Responsible AI in our Azure AI organization, which means I spend all my time now on the topic we're talking about today. But generally, my goal is to ensure that we're figuring out how to take new AI technologies and develop them responsibly and ensure that customers can build on top of them responsibly. And with this new generative AI wave, that means I'm spending a lot of my time also working with different teams inside of Microsoft to kind of show how this can be done at scale. So we worked really closely with GitHub Copilot. I've recently spent all my time sort of on the responsible AI development of the new Bing. And now we're looking at how to take all of that and enable everyone else to use it.
So this isn't like oh no, we need to be responsible here at the end. This is something you've been working on for years.
Yeah, responsible AI at Microsoft actually sort of officially the date we say started in kind of 2017, but we actually even had started groups and research before that. But that was sort of the moment we started figuring out how are we going to do this in our products and how are we going to do this at scale. And with each sort of new generative AI model that's come out, it's been a new opportunity for us to take the ideas in research and really figure out how to put them into practice and then turn that into platform technology. And so actually when GPT-4 came out, this was the first moment that we were ready to do responsible AI from the beginning. We actually had an elite team of red teamers were basically the first people to touch the model to assess what it could do, what it couldn't do, what the risks were, so that we were just ready to go from that moment and kind of do the next wave of work at the same rate that we were doing application development.
And it's interesting because it's kind of like a chicken and egg problem. We want to do this stuff responsibly, but you got to know like how are people going to break it, because this is unlike any other software we've built before.
Yeah, and that was actually and that's part of why we bring in red teams and people whose entire mindset is just how do I break this, in order to kind of bring that to it so we can see all the ways it can be broken. Now, these models are really large surface area, right? They are so powerful, they can do so many different things. And so we've actually had to bring in different type of experts, I think, who've never red teamed something before to do that, but who had domain expertise, right? National security expertise, legal expertise, fairness expertise to do that. And so even that kind of process we've had to expand. And it still was, I think, a big, open question with the development of some of these newer applications, because it's so new, we don't know how users are going to use it. So it might also break in ways that we weren't expecting because we just had no idea someone would think to do that with the technology. And so that's something where we're just constantly working to try to get ahead of it before we release things. But it is one of the I would say exciting challenges of this is just all the things the tech can do and all the creative ways people use it.
So let's back up a minute and let's talk about responsible AI in general, and then responsible AI as it pertains to large language models like ChatGPT. What do you say about that?
Yeah, that sounds great.
All right, so let me bring up, because you told me to show some slides here. Here they are.
These are my beautifully designed smart
So
art
these are
slides.
for those that are listening on Spotify, it's a circle that has it almost feels like you use the built-in PowerPoint stuff, right?
I did. This is, in fact, PowerPoint designer at work putting smart art to use. But I think this framework has actually been really helpful for people in terms of thinking about responsible AI. And so I think it is a powerful circle for us to look at. And so if we look at each of these steps, the first one is what we're just talking about, identify. We have to figure out what are all of the potential challenges that we may have with the technology that we need to take into account when we're developing it. And so this first step is actually a place where we have had to really bring in a lot of expertise and innovate to figure out what are all the different ways that this could cause sort of responsible AI difficulties. And so, as I mentioned with GPT-4, the first step we did for this is we brought together a group of experts with all different types of domain expertise to understand what the raw technology could do. Then, once it was developed in the application, we had ongoing red teaming occurring weekly to identify new potential issues. You can also have processes here where users could submit an issue that they see, right? And that would allow you to identify new issues that maybe you hadn't seen. And so, constantly trying to look at something from every angle and identify all of the things you have to take into account. And this is a really key step because this sets you up for what do you need to do to measure those issues and what do you need to do to mitigate those issues. And so this one comes first, but it's also sort of evergreen, and particularly in these large language models have large surface area, you're constantly needing to kind of identify and understand more deeply. And so this is one where we've really had to do a lot. And the nice thing is that at Microsoft, because we have a lot of expertise in this space, we're able to do the first wave of this and kind of do this on the raw technology and share that information out with customers. And so if you look, for example, in Azure OpenAI, if you look at our transparency note documentation, which is the responsible AI documentation, just part of your regular developer docs, we will provide the different issues that you need to look at so that you don't have to bring in all of that expertise. You have a great starting point kind of coming from our expertise, and then you can really focus on what's unique for your application and your domain expertise.
And the cool thing about this is that it requires you to have a diversity of people because the surface area is so large. You're going to have to measure, or not measure because we're not there. That's the part I don't understand that hopefully you're going to help me with. But you need to identify from a large, different points of view in order to make sure you cover the surface area.
Yeah, absolutely. Both because users use it in many different ways and because there's so many different content types. And then you also, at this point, also need the technology expertise, right? There's different ways the technology can behave. So you really have to bring all of those together to do this step, especially when you have a foundational new technology like GPT-4.
So this is where I understood this was, I work with someone that you work with, Bernush, who taught me, you need to measure, you need to not measure, but you need to identify the harms that you may cause to people before you start doing this. But the second part that I have a hard time with is how do you measure that? And that I think is the second in this beautifully designed circle by PowerPoint.
Yes. And I think measure, it's true. It's a really important step to understand, is this harm being realized and at what scale? And so we think of identify as just an existence proof that this could be a harm or it's happening in this one example. Measurement is the thing that's telling you, oh, actually it's happening in 90% of the examples, or it's only happening in Spain for some reason, right? And so measurement is a lot giving you that actually robust approach. Now, the challenge that we had was we had a great approach. For example, if you take quality of service fairness, which I'm sure something Marnush has come on and talked about, but this is the fairness and the accuracy of the model, right? And so that we have a robust measurement approach, right? You're actually looking at the factors and groups you want to measure, you're designing data sets, then you're looking at the score. Now, a challenge we've had in generative AI was The harm type that you see for fairness is what we call representational harms, which is how people are represented in the content. And all of these types of fairness are in our responsible AI standard. So, and that's public now, so you can go check it out. This is goal F3 in the standard. But this was something we really struggled with, which was how do we measure that? And good, I like the link coming up there. Thank you.
Yeah, I got you.
And the responsible AI standard, we didn't really know how to do it. And what has happened is that generative AI is not only an amazing tool in general for many different types of applications and a responsible AI interesting surface for us to work, it's actually an amazing responsible AI tool. And so what we have discovered is that actually GPT-4 can work great for responsible AI measurement. It actually allows you to better understand if the harm is being realized. And so we've started really building a lot of new measurement based on these new technologies. And thank goodness that this has actually happened, because this is also the time in the rise of prompt engineering and meta prompts, which we'll talk about in a bit. And if you haven't yet really played around with meta prompts, you will find it's wild, right? Like a single change in a word can change the whole application behavior, and it can change the whole responsible AI behavior. And so to do that robust kind of engineering where we're going between trading off quality and safety and trying to get the best of all of them, if we didn't have measurement, I don't know what we would have done, right? And so this has been like just a critical step to actually make this work. And also because, as we were saying, it's such a large surface area, you can't possibly just probe it all manually and feel like, oh, I know it's working well in all of these cases. And so measurement, I think I just cannot say enough about how much people need to invest in measurement. And, we're working to make this easier for people, of course, but I think we're really going to see this as a key responsible AI thing going forward.
So that's an interesting thing, because if I understood you right, I don't know how much you can say, because if you can't say something, that's cool too, because obviously I think Microsoft is still working on stuff. But I heard you said it's such a large surface area and you want to measure stuff, and you said something about GPT-4 doing the measurement. Am I getting this right?
Yeah, and we had said a little bit of this in the kind of Bing launch keynote, but generally we have been using the OpenAI technology to both like simulate interactions so that you can be having conversations at scale. And then we were using another copy of the model basically to score those conversations. And so that allowed us to make basically automated measurement pipelines. And there's a lot more to it to make it work for all the different types of responsible AI harms that you want to consider. But that being able to do that has just been game changing for us.
And that's interesting, because as I'm thinking about that, this isn't a new concept, because you remember generative adversarial networks did similar work in that, like, you had one model producing a thing and another model checking if a thing was fake, and as they fought each other, they both got a lot better at doing both.
Yep. Yeah. And I think it's like the same kind of concept, but the difference is now that we have an incredibly powerful language model, it turns out that all of these responsible AI concerns are in language too. And so it has such a more sophisticated understanding of language that it's actually good at it, right? And that's, I think, the difference is we could have done it before, but it wasn't good.
So now that we can measure, the question becomes, because, like, as I understand these things, and I've said this before, large language models are giant sophisticated text calculators, wherein you give it text and it produces the next n likely tokens, I guess, is the way I think about it. Once you've found or measured a harm, whether it's representational or any of the others, how does one go about mitigating or fixing?
Yeah, that's I guess the question we're asking ourselves every day.
Yeah.
And I think that this is actually a front that has gotten a lot more interesting and exciting as well. So even let's say a year ago, we were really just focused on one mitigation, which was the external safety system that goes around the model. But now there's so many more options available. And so if you want to go to the other side, slide, Seth,
Let's
then we
do it.
can look at that. So originally, as I was saying, all we really had was putting a safety system around the model, which is kind of this second layer. And that allowed you to just like sort of crudely clean up when the model made a mistake. And I think that now we're seeing we have a lot more tools available and that we want to use all of them. And so if we start at the core model level, if you want to animate this first one, one of the things that's really kind of new and exciting in the research domain, but is now actually starting to become a reality, starting with ChatGPT and GPT-4, is us using RLHF, which is reinforcement learning with human feedback, as a responsible AI tool in the model itself. And so teaching it how to respond to certain types of questions or where not to respond to a question. We've also been using RLHF to reduce, well, the demo we're going to look at, to keep the model more grounded, right? To have it stay true to the data that we've added for the generation. And so this is a key mitigation that's now available. And this is something that OpenAI is doing, and we're doing very closely with them on behalf of our customers. And so then these models are available in Azure OpenAI, and so you get the benefit of this work from us. Then around that, yeah.
And that's, if I may, and so that's interesting because the way I used it, and now I'm already starting to see how I did it incorrectly, is I just called the model with whatever prompt generative thing I did. And you're saying that there's more to it than just the model. You could also fix the model, air quotes, with RLHF to make it a little bit more understanding or generate better text.
Yep, exactly. And we're teaching it in many different ways. They were first teaching it to be more aligned with users. The term they use is alignment. And that's part of making it responsible too. You want it to do actually what you want. You want it to understand you, and you want it to follow your instructions. And then they took that same technique, and we've realized that we can actually also use it to understand when we don't want the model to respond for certain like safety reasons, or if you want the model to be better at a particular task, like looking at that input data, then if you want the model to stay grounded in the input data and not just make up random stuff or change the data, that's something that we have trained into there. And so if you look at Bing, there's 3 different modes now, right? You have creative mode, where like, oh, I really wanted to brainstorm. And you've got balanced mode, which is kind of your general purpose mode. And then you've got precise mode, where you want it to stay really true to those search results. You want it to make sure that it's staying very focused on those. And that's a model that we built using RLHF to be more precise, to stay truer to the search results. And so that's how, so this is a new technique that we just see enormous potential in. And so I think you'll see a lot of innovation on this space. And if you use GPT-4 in Azure OpenAI today or ChatGPT, those both have a safety layer built in using RLHF.
I see. So is that safety system this outer thing, or is it more than, because I thought, and this is again my naive understanding, I thought RLHF produced newer weights that were regularized by the old model using, I think it was KL divergence, if I remember right.
Yeah, so it's using, so that's producing a new model. And then we have a safety system around it. And the reason for that is that you want defense in depth here. And so if we can train the model to respond better to particular queries, then that's even better, because you can get like a more productive, useful answer. And then the safety system can be kind of that last line of defense of like, either someone's really hammering it, and so you just want to kind of shut down that interaction, or if you have the models still made a mistake and produced an undesirable response, then the safety system's there as a watcher system to clean up for the mistakes the model had. But hopefully it's triggering less. I saw someone say in the chat that they had triggered the designer RAI system, right? And you did it, right? You get a notification like it couldn't respond or whatever. Well, we'd like to minimize that to be, again, just the last line of defense. And most of the time the model is able to do it itself. And so RLHF helps us do that.
I see. So if I'm understanding right, RLHF helps the model weights to produce better based upon whatever human feedback, a better response is based upon the human feedback. The safety system is the software around the response that then does stuff with the text, like, someone managed to get around it, we're going to just give a flat message out or something, or whatever it is that you decide to do. Is that right?
Yeah, exactly. Like if someone either is like trying to jailbreak the system, then you may just not want to even have the model respond, because we know that that's a weak point for the model. Or we can like filter on the inputs, or you can look at the outputs and say, whoa, we did successfully jailbreak it and confuse it, and the output is harmful. And so then we can filter on the outputs. And so this is built into Azure OpenAI today. And we have a variety of models that work on hate, violence, self-harm, sexual content. And we've got newer ones coming as well. And those are multilingual, and they look at the inputs and outputs exactly to make sure that the model didn't miss or make a mistake.
So the safety system could be, in essence, like a moderation system on
Exactly.
what comes into the model and what comes out of the model.
Yeah, and so you could decide you don't even want to respond to certain types of queries, and then we can configure the safety system to be much more restrictive on the input for those query types, for example. So that's the idea of that, and that's been integrated in Azure OpenAI in kind of a preview form for the last 6 months or so, but we majorly upgraded it to more advanced and much higher quality models, actually leveraging, again, the power of GPT-4 to really use that to improve our machine learning processes and make these safety system models a lot better. And so we're pretty happy with the performance of them now, but we'll continue to be improving them. And then as we find new types of responsible AI harms, then we're adding more content filters in there for different harm types, so that we have more built-in coverage and customers don't need to worry about it.
And that's something that's part of Azure OpenAI.
Yeah.
In other words, I don't have to build my own safety system. It's already built in.
Yeah, and I think for really, let's say, like high stakes applications or particularly sophisticated applications, you might see a combination of our built-in safety system, which is made to just understand this is sexual content, this is hate, right? It's looking at the content types with sort of domain-specific classifiers. So if you take what we built for Bing, for example, we took sort of classifiers that were built specifically for search and understood search better, and combined them with this safety system so that you had a really kind of robust defense. But for many applications, this is probably enough. It just depends on what your domain is.
Got it. And is that the application layer, or is that something different?
That is the safety system layer, and then what we call the application layer is really how you're thinking about designing the application. Like, what do you want to do with this model? And this includes both the architecture, right? How where is data, if you're injecting data, where is data coming from? How safe is that data, for example? What are the outputs? Are the outputs reviewed by a human? Are the outputs something that goes straight to automation, which I don't yet recommend, right?
Yes.
And so like how you're choosing the application architecture is going to impact sort of your safety stance of your system. But also, I think we're going to look at more later is the meta prompt design. Part of what we found in particularly most recently in this new wave of applications we've been launching is that the prompt, or the meta prompt, the system part of the prompt, is enormously powerful. And like, nobody should be shipping an application without adding safety elements into your meta prompt, because it just works great. It's exactly like what we were saying about the core model too, where that's a chance for you to guide your application to give the right types of responses for users and have a much better user experience than just triggering the safety system because you sort of failed, right? And so meta prompt engineering is a place where we're spending all of our time. You also then have to think about the UI and the UX, right? Do users understand what it's doing? Do they know they need to edit? Do they know they need to review, right? And so all of those are mitigations that you have to think about at the application layer.
Interesting. So this is now, like, I see how it goes from less specific when it comes to safety to more specific, because there's certain safety things with the application layer. Like, for example, even just labeling that this was mechanically generated is an example of you being safe with this stuff. Understanding the difference between co-creation and execution, I think, is also important, depending on the risk of what's going on. Like, if you're trying to power a nuclear power plant with this thing, you should probably have a human looking at whatever this thing generates, basically.
Yep. And a big thing we did at the application layer for Bing was having the outputs have references, right? And that enables users to understand the content, where it came from, the authority. It also is, another line of defense for, content that's ungrounded, where it doesn't actually match the sources. Users have a path to investigate. And that's a decision that was made at the application layer that has a lot of benefits from a responsible AI point of view and from a user point of view. But that's not something we're doing at the sort of core model level.
And that makes sense, because how could you ever know, like, specifically for this application, how we should be safe? But there's basic grounded safety that we need to have. But then you need to think about, for your application, what additional safety measures should I have?
Yep, and that's exactly where we will keep striving, and I think we have a great starting foundation already of providing all of the capabilities you need at the platform layer, but you're going to have to customize them. You're going to have to think about your domain. You're going to have to provide that expertise, and then the way you design your application has to take all of that domain expertise into account as well.
I see. So is because I've heard of a new technique. Well, I don't know if it's new, but a new technique called RAG, which is retrieval augmented generation, where you inject data into the prompt in conjunction with the meta prompt. That would be something that happens at the application layer. Is that right?
Exactly. Yep. And like the decision of whether or not that data is controlled, or whether that data is coming from the open internet, or whether that data is ranked based on a safe ranker or something, all of that is going to change sort of the risk of your application. And that's all architecture decision and application layer decision. And so that's something that you need to think about as the application developer. And we, since we have the benefit of being able to work with many teams inside of Microsoft and many customers working with us outside of Microsoft, as much as possible, we're trying to take the best practices we've learned and publish those with Azure OpenAI, so that you can learn from what we already know. But that's still something you're going to have to do for your application at this point.
Makes sense. So the last little bubble area, positioning, that I've never heard of that. What is that all about?
Yeah, this is maybe not the best word, but this is like even how you position the application or the technology or the purpose of this, where if you're like how you set expectations and what you say it's for. And an example that I've given for this is if you look at the Galactica launch from Facebook, that was really not, that was chatbot, right? It was like not well received, because it was for generating scientific content that was supposed to be high authority. And when ChatGPT was released, it was actually, released as like a small research launch that was actually for us to learn how to be more responsible and like understand how people wanted to interact with this. And so it was a very different positioning about what the purpose of this was. And the reaction from like the responsible ad community was just totally different into, whether or not this was a reasonable thing. And so how you talk about the technology and its capabilities and its limitations and what domain you're putting in, all of that actually is a big part of the responsible AI story, and one that I think people do not often think about. And it's really about like choosing which problem you're going to solve and talking about how you're going to solve that problem with generative AI.
And that's awesome, because I personally, I have always suggested to folks never to imbue these things with any human characteristics whatsoever, or
Yeah, that's a great
anthropomorphize them
example.
at all, because then it endows them with agency they neither have nor aspire to. And that's my baseline with all these models. Is that a part of positioning?
Yeah, absolutely, right. And how you are positioning, yeah, what this AI entity is doing, and if its position is human, you're setting yourself up for both enormous expectations from users, and then also additional concerns like users forming an emotional attachment with it, which is a whole different thing, right? There's a lot more work that you have to do if you want to play in that domain, right? And so absolutely, I think that's a best practice, and exactly the type of positioning that's really important.
There's also this notion of a collaboration versus an execution application, right? Where you position this thing as it will make stuff for you to review, versus it will do stuff on your behalf. Is that another example of positioning?
Yeah, absolutely. I think it's, between the positioning and the application architecture, but I think, when we are very specifically naming our applications at Microsoft Copilot to emphasize the point that they are a collaborative tool with humans, with the user. They're not an automated like replacement tool. And that's absolutely important, because a key mitigation in responsible AI for all the ways we've developed this is there's a human in loop, right? You can use this to generate wild and crazy text to help you get started, to help you brainstorm, but you're going to go and edit it before you send it or before you publish it or something. And so if you were trying to take this and have something that's just going, like, say, content straight to publishing, that would be a very different thing. You need to design a lot of different responsible AI concerns, right? And so this is absolutely a huge part of it.
I love it. So that makes sense, and I love how it goes from specific to very general, depending on what you're trying to accomplish. So I feel like before anyone makes any of these kinds of software with these kinds of models, they need to sit down and really consider, who is this for, what are we doing, and how could it potentially harm them, and how can I mitigate
Yeah.
mitigate that? And that's a lengthy conversation that's probably ongoing throughout development and implementation.
Yeah, and that's where that identify step that we were talking about earlier, the tool we use inside of Microsoft is called an impact assessment, and that's kind of the framework that we use to exactly go through that process and kind of write it down. But as you were saying, it's actually just completely iterative, because uh, if you look at that implementation stack we were just looking at, right, there's a lot of moving pieces to that. And so it's not like, okay, you think about it once, you build it all and you ship it and it all just works, right? And so we were just in every application we've shipped, we were just constantly, almost daily, going through this entire loop and like making changes. The measurement says they're good. We've shipped them. Now we've sent the red teamers back to test them, and we've identified new issues, and we've enhanced our measurement, and then we've changed the mitigations, and we're just going around this loop all the time. And then, of course, when you ship it in the real world, that's what this last step is about. And that's the humble moment when you realize that, yes, of course, users have decided that there's something really great about your application that you didn't even think about. And so the operational piece is something I think people, organizations that have deep operational experience, often think about, but a lot of application developers may not think about that. You need to ensure that you have a way that users can give feedback, and you need to be able to adjust things quickly. And so part of this whole stack development is enabling you to very quickly be able to make small changes to address new issues you see, right? If some concern comes up and you have to start completely from scratch to fix it, that's going to take a long time. And so you want to design all of this to ensure that you can adapt very rapidly. So an example for this is that our new content filters in Azure OpenAI, they have different severity levels. And so, for example, if you are a gaming company, and you just shipped with our default settings, you might find that we're over filtering for violence if you're, a game like that. We can just change that setting now and get better behavior. Or we've gone the other way, where we're changing the setting to be more conservative if you're in an application where you want to be very sort of sensitive with content, for example, if you're working in an education setting. And so that's an example where we've built in this agility into our system so that we can adjust on the fly, right? And we've also built into our system, for example, block lists, so we can quickly add a word to block something else. But the measurement step enables you to also more quickly make meta prompt changes, because you can try different things and test, measure quickly to see if it's okay, and then ship a new meta prompt. And so this last step is really important, and something that you actually need to think about from the beginning. How am I going to design this to be agile? Because this is a fast moving space, and you've got to be able to adapt.
And it's like I'm sitting here remembering because I'm old. I remember my first programming class was Java 1.0 in 1996. And that stuff was like, okay, first you got to plan your application. Now you're done planning. Then you got to put it into rational rows. That's how old I am. I'm dating myself. What's comforting to me is that obviously all of that was wrong, and everyone understands that software is something that we need to babysit. You're saying we're not throwing out what we've learned from building other software. This one just needs to be babysat in a specific way.
Yep. Except now so same pattern, same everything, except now you need someone who can quickly make a decision about how to adjust something related to hate speech, for example. And so all the same machinery, but you have to adapt it for the responsible AI process that you're running. And so we've had to kind of upgrade each of our steps here, thinking about the specific responsible AI concerns, which is why that identify step is so important and why it was so critical for us that we did the responsible identification at the very first moment that we got GPT-4. So we had all of that time to update this whole thing in parallel with the rest of the application development to work for responsible AI.
How awesome was that? Sarah is pretty amazing. You just saw Sarah Bird on being responsible with large language models. Last but not least, Marah does an awesome demo on how to be responsible with classical machine learning by looking at data. Take a look. All right, so that sounds awesome. I feel like, Marah, can you show us how this is done?
Yes, today I'm going to give you a demo of this. Okay, so what you see here in today's demo, I'm going to show you how we can combine our 3 responsible AI tools. And so what you're looking at here is a Jupyter Lab environment where I've already installed our Jupyter Lab extension, RAI Tracker, our first tool of the day. So a little bit about RAI Tracker. It's a tool to help you compare, visualize, and validate different model experiments and improvements. So, and by the way, you can install it yourself very easily with a simple pip install.
Ooh.
So let's jump right in here. I have my first notebook, which I've already imported, my baseline notebook. Okay, in this notebook, I'm loading the UCI income dataset, and I'm training a LightGBM classifier for a binary classification where if the individual in the dataset has, for your reference, an income higher than or equal to 50K, then it's a positive label, otherwise it's a negative label. So before training my model, I am doing a little bit of data pre-processing. So using our second tool, the RAI mitigations library. And a little bit about it, it's a Python library. Again, you can install it with a simple pip. And it offers what we call a non-fragmented experience, where you can improve the data in a way that improves the performance on the model. And so you'll see multiple ways of how to use this library throughout the demo, but here it's very simple. We're just using it for an imputation and encoding pipeline before training the model. And then simply I just train, save the model, and then what I do is I register it in RAI Tracker. And I've already registered it here, but I'll show you a little bit what the interface looks like. We have our model, but along with the model, we have a test data set that the tracker can use to evaluate the model throughout these experiments. Okay.
Can I ask a couple questions?
Yes.
So the first question is, this pipeline, is that like a scikit-learn pipeline, or is that pipeline like something from the RAI toolbox?
The one I'm using here, it is a scikit-learn pipeline.
Perfect.
Yes,
Perfect.
But every mitigation within the pipeline I'm using is from the RAI mitigations library.
I see. So the data, for example, the one-hot encoding, I'm guessing, is what the encoder is doing. Is that something that's in the mitigations library to be able to understand what's happening as it's going in? So that was the first question. The second question is, you clicked on something inside of the Jupyter Notebook that showed a model thing. Is that part of the RAI tracker as well? Do you know what I'm talking about?
Yeah. So I'm guessing you're talking about
Yes,
this.
exactly.
This is part of the tracker. This is part of the tracker interface. I've already registered the model, but here you will see a little register word that says register. You click on it, and then you can upload your model. You choose the platform, and then you choose whatever data set you want to evaluate it on. This is all part of the tracker interface, and it's it's clean. It's easy for the user to use.
And this you would do after you train, like, for example, this LightGBM model with the pipeline.
Correct.
Got it. Okay, cool. I understand.
So in the back end, I've saved it and then I've registered it. Correct.
Fantastic.
Okay. So We'll look a little bit more about the accuracies and the metrics of this model in a little bit, but before I want to take a closer look at the data itself. So, and that's where our third and final tool, which we've talked about here on the show, but it's the Responsible AI dashboard. I'm just going to remind you of what it is. So
Okay.
here using the RI widgets Python library, I'm propagating the widget, and I've opened it here. And the first thing here we see is an error analysis tree. So we can see an 18 or 19% error rate, which matches our 81% accuracy here. But if we look at the data itself, not just overall, but for specific cohorts such as this one, we see a bit of a full circle, which indicating there's more errors. For this cohort here, it's for individuals whose relationship is husband or wife. So let's say they're married individuals, right? So if we have almost a little more than 35% error rate compared to the non-married individuals with only a little more than 5% error rate. So that's quite a big difference, right? And it could be part of the reason why something we can mitigate and improve in the model. So to do that, I'm just going to take another look here at something in the label distribution. Okay, so we have our full data. We can see there's a skewness here towards the negative label. There are less positive labels than negative labels. But what about the cohorts that we saw just up there? And mind you, here I've already created these cohorts, but using this button right here, and you can very easily create any cohorts you like, combining different aspects of the data. But here we have on the merit cohort, what we noticed is there's a bit more of a balance, right, compared to the full data. And let's just keep that information in mind as we move forward with our experimentation. And before moving on, I'm just going to look at the not merit cohort.
Ooh.
We see a bit more similar to the full data. Again, we see the skewness towards the negative label. So now that we know this information, let's go back to the tracker and try to build on top of that to mitigate some of these issues and improve the model itself. Okay, so I've already imported my second notebook, same data set, also like GPM classifier. But what I'm doing here before doing the pre-processing and training the model, I'm using an extra mitigation here. Again, from our library, from the RI mitigations library, using the rebalancing mitigation to rebalance the full data. And here I'm using an oversampling strategy where we're just sampling enough data points to create a balance between the two classes for the full data set. And so the same thing here, I get my new X and Y after resampling, the same pipeline, and then save the model again. And then, of course, I have to register it. Mind you that I'm using the same data set, the same test data set, because I would like to compare the two. And of course, here, we can look at the accuracy. There's some improvement. But before getting there, what I want to see, again, I want to look at this label distribution post-rebalancing. And I'm going to do that here within my notebook very easily using one of my favorite parts of our RI mitigations library, and that's the cohort manager. The cohort manager class, it lets you do what we did in the widget where we created or looked at these cohort within your Python code very easily. You don't have to do it. You don't have to do it manually. You just give it the filters that you'd like to add for your cohorts, and then using a transformation pipeline, we can simply create these cohorts and look at the distribution, plot the distribution for both of them. Okay, so here we have our full data. Obviously, we did a rebalancing over full data, so as expected, we have a very balanced full data set. But if we look at the married cohorts, we can see there's a bit more imbalance than before. And that's because we have a lot more positive labels now. And that's probably because in the beginning, most of the positive labels were in the merit cohorts. And so after the rebalancing, they came from the merit cohort. Compared to the not merit cohort, that's still very much imbalanced. Okay, so what we can do here, now that we have all this information, we can compare our baseline to this new model. And now that I've registered both of them, I can click on this compare models button here, and I will get this tab where I can see a visualization of this comparison. So I've selected both the baseline and this new notebook.
Mhm.
And looking at the accuracy, we see some improvement, right? But mind you, there seems to be quite a bit of drop in the precision. But why is that? Let's look at the cohorts again. We can create the cohorts within the RI tracker itself, not just in the mitigations library or the widgets, but again, all these tools are meant to work together. They're meant to be compatible. So I've created here already are the married and not married cohorts. Again, similar to like in the widget in the library. So I'm going to add them in for a more detailed look. Let's start with the baseline. You can see that the not married cohort already has quite a decent performance in the first place. The married cohort post rebalancing, the married cohort seems to have improved in accuracy, but again, we see this drop in precision and not much change for the not married cohort. So this really gets us thinking, if this is the case, why don't we try a more targeted approach where we can simply focus on the married cohort? And since the not married cohort already has decent performance, why don't we just leave it as it is? And again, this could help because most of the positive labels were sampled from married cohort. This could really be what's hurting the precision. So given that, our final notebook here, which
Let's pause right there just so I can ask a question. So the first rebalance, you're basically rebalancing based upon the label. Is that right?
Correct. I'm rebalancing the full data set based upon the labels. Correct. I want an equal number of positive and negative labels for the full data.
I see. And when you do that, does the data set get smaller, or do you resample multiple times to make the data set the same size-ish?
You can, so given an oversampling strategy, we synthesize some new data sets, some new data points, if that makes sense.
That makes sense. And so when you were, because the first thing we noticed is that there was an imbalance in the label. We rebalanced the label, and when we rebalanced the label, we noticed that we were having some precision problems in another cohort of data because there was an imbalance in that particular feature as well. Am I getting this right?
Yes, and because we did the rebalance over the full data, it couldn't, it wasn't targeted towards specific cohorts, so it didn't know where to add new positive labels and where not to add new positive labels. So that makes sense. So it was a very blanket approach, and so it didn't give us. That's why it hurt our precisions for the married cohort, for example.
And that makes sense because the married, not married, there was an imbalance there to start. And when we oversampled, we kind of kept that. We oversampled, balanced one label, but it didn't cause the other one to fix. And so now we're going to go look and see how we can fix that particular problem. Okay, makes sense. Let's do it.
Okay, so our last notebook here. All right, so what I want to do here, I want to focus on the married cohort. So again, using our cohort manager class, we can create the cohorts very nicely. And this time I'm not just using the cohort manager just to plot the label distribution, but rather I'm using it to train to fit two different transformation pipelines. And so our first pipeline you can see here has a rebalancing, mitigation, but the second pipeline is empty right now. So after transforming the two cohorts, I resample, I get my new X and Y. And this way, the not married cohort, as we said, it's untouched. I did not do anything to it. So post this, I can do over the new X and Y, I do the same pipeline and the same estimator, save my model, and register it, of course. And before looking at the comparison, back to our tab here, let's do the same thing and look at the new label distribution. So we see over the full data set, a bit more balanced than before. However, the married cohorts are perfectly balanced, and the not married cohorts have not been affected by the rebalance specifically. Right. And that was our goal in the first place, right? So let's see how that looks like in the comparison tab. Okay, so of course I've registered the model with the same data, with the same test set, and I'm going to add it in right here. Okay. So over the full data, we see a 4% improvement in the accuracy. That's pretty nice. That's better than before. For the married cohort, a 9% improvement in the accuracy. Again, that's even better than before. That's great. But as expected, the not married cohort has not been affected. But more importantly, what I think is the most positive outcome of this is that the precision was not as hurt. We have a lower hit in the precision. And this is, again, the benefit of this more targeted approach, where we focus on the cohorts that need our improvement rather than just a blanket mitigation. And so this is basically how we use these tools together to iteratively build and improve our models in a way that tells the full story.
All right, my friends, and that wraps our show for today. We just saw Marah do an awesome demo on how to be responsible with classical machine learning by looking at the data. We also saw Sarah Bird on being responsible with large language model applications. And then the first person we saw was Marco on how ChatGPT works with grounding. Make sure you tune in next week where our show is going to announce Azure Content Safety, creating safer online communities with multimodal content filtering, AI with Sarah Bird and Tony Jing. Thank you so much for watching, and hopefully we'll see you next time. Take care.